Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very warm welcome to all of you to this session of previous year papers on the subject of heat transfer. So today we will discuss the previous year questions of critical thickness of insulation. Definitely this topic is a very important one when you talk of engineering applications, because this topic will tell you that for all those wires around you, what should be the thickness of insulation around it, so that not only the insulation is protecting you from electrical shocks, but the insulation is also increasing the heat transfer rate. It is also increasing the heat dissipation rate and preventing the rise of temperature of wires, because if the temperature of wire material will increase, ultimately the wire material will melt or vaporize, right? So that we have to avoid. And yes, here the purpose of insulation is to increase the heat transfer rate. And when we are talking of supply lines or discharge lines in case of power plants, we want that the hot steam which is flowing in the pipe, it should not lose heat. So the thickness of the insulation must be chosen in such a manner that the heat dissipation is minimum. Otherwise what will happen? The steam which is going into the turbine, the energy of that steam will decrease and power production will decrease. So the same insulating material can act as a good conductor also. I mean, same insulating material can increase the heat transfer rate or decrease the heat transfer rate depending upon the thickness chosen by you. And we will discuss the practice questions of the same. So, एक बार check कर लेते हैं, एक बार basic सा idea revise कर लेते हैं. Let us just revise a little the theory that we did. So, I hope you remember, you guys told me that let us suppose, तो जो भी students हैं, those students who have done the course with me, so in particularly those guys told me that, sir, let us suppose there is a wire or a pipe. So, wire carrying current or a pipe carrying hot steam. Now this is the outer radius of the pipe. Okay, so basically the outer radius of the wire or the pipe. So wire has only one radius, but when we talk of pipe, there are two radii, right? So the outer radii of the wire or the pipe is R1. And what we want to do, we want to add an insulation. We want to add an insulation on the pipe or the wire which has a thickness. How much? It has a thickness T. Okay, what is the thickness? T. So I have not made completely concentric circles, but I hope that is fine. So the thickness of this insulation material is T. So obviously you will say, if this radius is R2, the radius of the outer circle, that will become the radius of inner circle plus the thickness. So what is R1? R1 is the radii of the pipe or wire or inner radii of the insulation. So what is R1? R1 is the inner radii of insulation, inner radius of insulation. And R2, that is the outer radius of insulation, outer radius of insulation. Now in the entire thermal circuit, the insulation is going to offer two resistances. So one resistance is the resistance to conduction. So basically whatever heat is produced in the wire, that heat will go from first of all that heat will reach the outer surface of the wire. So there is some conduction within the wire. Then from this outer surface of the wire to the outer surface of insulation, there will be some conduction within the insulation. And then from the outer surface of insulation to the fluid, there will be some convection. So when you talk of insulation, insulation has two resistances to offer. One is the resistance to conduction and the other one is resistance to conduction from 1 to 2, and the other one is resistance to convection from 2 to fluid. Okay. So this will become the total resistance offered by the insulation. Now guys, I hope you remember I told you that R1, which is the radius of wire, that will depend upon the electrical aspect of the system. or R1, which is the radius of the pipe, that will depend upon the thermal or fluid aspect of the system. So for us who are designing the insulation, R1 value is same. R1 value is what? Same. Now suppose the thickness of the insulation is 0. So if thickness of insulation is 0, there is no insulation. In that case, R2 will be equal to R1. So thickness of insulation 0 means minimum value of R2. So minimum value of R2 is equal to R1, right? So when you will add insulation, there will be some thickness and R2 will be greater than R1. But in any case, R2 can never be less than R1. Now, I hope you remember I told you that if we draw a graph of the resistances in the system versus the R2 value. So what is the minimum possible versus the R2 value? So what will happen that as the value of R2 will increase, the resistance to conduction will increase. So resistance to conduction will go like this. So this is the minimum possible value of R2, which is R1. Resistance to conduction will go like this. And when we are talking of resistance to convection, the resistance to convection will go like this. The resistance of convection will decrease. So basically, if you increase the thickness of material, there will be more resistance to conduction. But if you increase the thickness of material, the outer surface area will be more. Therefore, resistance to convection will be less. So when you draw the total resistance, maybe the total resistance goes like this. And this particular point will represent the minimum total resistance offered by insulation. Minimum total resistance offered by insulation. So this is the minimum total resistance of insulation. Minimum total resistance of insulation. And corresponding to this, we will call the value of R2 to be RC. Okay? So the value of R2 where the total resistance is minimum, that is called as RC. That is the critical radius of insulation. What do you call RC? Critical radius of insulation. Critical radius of insulation. Guys, I hope that nothing is hidden behind me. Let me just give a glimpse कि मेरे पीछे कुछ छुपा नहीं है. नहीं, मेरे पीछे छुप गया है ना? So just a second. I will clear it out. So this is R convection. This thing which is hidden behind me, that is R convection. Okay. And RC is called as critical radius of insulation. What is RC? Critical radius of insulation. RC is the value of R2 when the resistance is minimum. So if we talk of resistance and heat transfer rate, so heat transfer rate will show opposite behavior to resistance. So see what is happening. As the value of R2 is increasing, the resistance is decreasing. If the resistance will decrease, the heat transfer rate will increase. And the resistance achieves a minimum. So heat transfer rate will achieve a maximum. Resistance achieves a minimum. So heat transfer rate will achieve a maximum. Now further, as the value of R2 increases, the resistance increases. So heat transfer rate decreases. So the value of R2 will decide what will be the total resistance of insulation and what will be the corresponding heat transfer rate. So I hope you remember I told you that for cylindrical bodies, RC is equal to K by H, where K is the thermal conductivity of insulation material and H is the coefficient of convection of the insulation surface and surrounding fluid. For spherical bodies, the same value is equal to 2K by H. For spherical bodies, it is 2K by H. So this you can write 2K by H for spherical bodies. So I hope everyone remembers this and there is no doubt in it. Okay? But guys, if there is any doubt, you feel that anything I have did wrong, or you feel that you are not able to understand anything, any doubt is there, any comment is there, any query is there, you can post in the comment section. Okay? And I will try to reply you from there. बाकी जो लोग जिन लोगों के पास मेरा नंबर है दे कैन डेफिनेटली कॉन्टैक्ट मी एंड दो स्टूडेंट्स मतलब आप कभी भी कॉन्टैक्ट कर सकते हैं, कोई प्रॉब्लम नहीं है. Now guys check, this is the first question. So this question was asked in 1993 also, 1996 also, same question. What is the question? For a current carrying wire. So guys always remember, when we want wire, in case of wire, the heat dissipation rate should be maxima or minima. Heat dissipation rate should be maxima. The wire must not store any heat. So heat dissipation rate should be maxima. So resistance should be opposite. Resistance should be minima. है ना? So it says for a current carrying wire of diameter 200 mm. So for the wire diameter is 220 mm. So what will be the radius of wire? It will be 10 mm. But I hope you remember that I write the radius of wire or inner radius of insulation as R1. So that is 10 mm. Now this wire is exposed to air whose coefficient of convection is given to you 20 watt per meter square Kelvin. So definitely this value is H. The maximum heat dissipation rate occurs. I think this is we want. For wire, we want the heat dissipation rate to be maximum when thickness of insulation is 30 mm, 25 mm, 20 mm, 15 mm. And for the insulation, something is given to you. Check with insulation, something is given in brackets. What are the units? Watt per meter Kelvin. I think these are the units of thermal conductivity. So thermal conductivity of insulation is given to you and they are saying when will the heat dissipation rate will be maximum. So you know that sir, heat dissipation rate will be maximum when the total resistance of insulation is maximum, and total resistance of insulation, this is minimum when total resistance of insulation is minimum, and total resistance of insulation is minimum if R2 is equal to RC, where RC is equal to K by H. Now guys, please note RC is a property. RC is a property. This is thermal conductivity of insulation by coefficient of convection with surrounding fluid. It is a property. Now it is up to you. If R2 is equal to RC, resistance will be minimum. And if R2 is much greater than RC or much less than RC, then resistance will be high. समझ रहे ना आप? तो आपको choose करना होता है कि R2 की value क्या रखे. So when you are designing electrical wires, you will keep R2 equal to RC so that resistance is minimum, heat dissipation is maximum. And when you are designing steam pipes, steam carrying pipes, then you will keep R2 much less than RC or much greater than RC so that resistance is high and the heat dissipation is low. So one thing we should remember, this is a property, this is a property, this is a particular value, and it is not necessary that R2 is equal to RC. It is up to you who is designing the insulation, whether you will take R2 equal to RC or not. Okay? Now in this case we know that resistance should be minimum, so R2 must be equal to RC. So if R2 must be equal to RC, what is RC? RC is equal to K by H. Why did I take K by H, not 2K by H? Because we have a wire. Wire is a cylindrical body. So this K of insulation material is 0.5. Please remember, this K is of the insulation material, not of the wire material or pipe material. And the coefficient of convection is 20. I think this will become 5 by 200, which would be like 1 by 40, or that will become 0.025, 0.025. Obviously K and H are in SI, so this radius also we are getting in SI, so this will be meters or 25 mm. So if R2 is equal to, so RC value is equal to 25 mm. So when R2 is equal to 25 mm, our objective will be achieved. Now many of us make a silly mistake. Fatafat say we mark 25 mm. But please note, this is wrong. Why this is wrong? Because this is the value of R2 and they have asked you thickness. They have asked you thickness. So how do you write thickness? Thickness is written as R2 minus R1. How much is R2? 25 mm. How much is R1? 10 mm. So how much will be the corresponding thickness? 15 mm. So when the thickness of insulation is 15 mm, the radius R2 will be equal to critical radius, resistance will be minimum, heat dissipation rate will be maximum. So correct answer is 15 mm. Okay. So I hope the question is clear. Please do let me know in the comments if the question is not clear. I will try to contact you. Okay? Please do let me know if there is any problem. Now let's move on to the next question also. Let's move on to the next question. So again a very simple question. So guys, ऐसा हो सकता है that out of the previous year papers, 2-3 questions I have missed out. But all questions are of similar types. So you need not worry about it. Why I am doing all these questions that I had from GATE exam just so that you guys are confident ki we can easily solve the GATE question. Okay, that's why we are doing all these questions which are actually same type questions only. But when I will have separate practice questions, I will try that there is some subjective kind of question which is like a little tougher. Now it says it is proposed to coat a 1 mm diameter wire. So I think the diameter of wire is given to you, that is R1. So R1 will be equal to diameter by 2, that is 0.5 mm. How much is the diameter of wire? 0.5 mm. With an enamel paint K equal to 0.1 watt per meter Kelvin. So I think they are saying that we will coat the wire with paint. So paint will become insulation. And what is the thermal conductivity of this paint? 0.1 watt per meter Kelvin. To increase heat transfer with air. If the air side heat transfer coefficient is 100 watt meter square Kelvin, the optimum thickness of enamel paint should be. Okay? So we want to increase the heat transfer rate. If you want to increase the heat transfer rate, resistance must be minimum. Therefore, R2 value must be equal to RC, which is equal to K by H. So if K is equal to 0.1 and H is equal to 100, I think this will become 1 by 1000. That will become 1 by 1000 meter because K and H is in SI units. So this will become 1 by 1000 meter. So that is 1 mm. So how much is R2? That is 1 mm. R2 is equal to 1 mm. So when R2 is equal to 1 mm, resistance is minimum. But again, please don't mark 1 mm directly. This will be a wrong answer because they are not asking you the outer radius. They are not asking you the optimum outer radius. They are asking you thickness. How do you write thickness? Thickness is equal to R2 minus R1. That is 1 minus 0.5 mm. So that will become 0.5 mm. So what is the optimum thickness to have minimum resistance and maximum heat transfer rate? 0.5 mm. I know the question was very easy. You can easily do it. But still again, अगर कोई भी doubt है, you guys can ask me. ठीक है? Now let's move on to the next question. So this is a question from 2006. अच्छा, ये वाला question. Actually, there is a mistake in this question. There is a mistake in this question. So first let us read out and then we will see what is the mistake. With an increase in the thickness of insulation. So if we increase the thickness of insulation, guys, I think let us do the other questions first and then we will do this question. उससे थोड़ा सा better होगा. आप लोग मेरे साथ आसानी से समझ पाएंगे. ठीक है? पहले बाकी question कर लेते हैं. This concept I don't want to introduce from this question because there is a mistake over here. ठीक है? So let us do the other question first. Now this is a question from GATE 2015. If a foam insulation is added to a 4 centimeter outer diameter pipe as shown in the figure. I hope you can easily recognize. I think the diagram is a little messed up, but this is 4 centimeter. This one is 4 centimeter. So basically this is the outer diameter of the pipe. This one is the outer diameter of the pipe. This one is the outer diameter of the pipe. Okay, this one. Outer diameter of the pipe. Now it says, in the figure it says, that this pipe material has a thermal conductivity of 0.1 watt per meter Kelvin. Pipe material, not the insulation material. For the fluid which is inside the pipe, coefficient of convection is this. The outside the pipe there is an insulation whose thermal conductivity is this. And outside the insulation with the fluid, coefficient of convection is this. It says the outer diameter, find out the critical radius of insulation. So what is critical radius of insulation? When R2 is equal to RC, which is K by H, we will have minimum resistance and maximum heat dissipation rate. But first of all, in the question, two thermal conductivities are given just to confuse you. Okay. So I think मैंने शायद यहाँ पे नोट करते करते गलती कर दी है. Most probably these two thermal conductivities were not equal. ये thermal conductivities equal नहीं थे. Otherwise इसका कोई फायदा नहीं होगा, है ना? So let me do one thing. Let me just confirm what were the thermal conductivity values. बस मुझे एक मिनट दीजिए. Actually मेरे पास बुक पड़ा ही है. I will confirm. So it was here only somewhere. Just a second, guys. Just a second. Hardly it will take a minute. So I have the book with me. So actually I have a lot of books with me which are previous year papers. So from there I am able to recognize that these topics are asked a lot. These topics are asked less. So definitely there is an advantage of this thing. So thermal conductivity of pipe material, that was 15 watt per meter Kelvin. Obviously it has to be 15 watt per meter Kelvin, because then if both the values are same, then there will not be any insulation, right? So here they are trying to confuse you, because the thermal conductivity is of the insulation. So this will be 0.1. And the coefficient of convection is between the insulation and surrounding fluid, not between the pipe and the inner fluid, है ना? So this H will be 2. So 0.1 by 2, that is 0.05. Obviously we have written the things in SI. So this will be 0.05 meter, 0.05 meter or 5 centimeter, है ना? So what is the critical radius of insulation? That is 5 centimeter. So when R2 value is equal to 5 centimeter, heat dissipation rate will be minimum. And guys, please check what have they asked. They are asking just critical radius of insulation. I am sorry if the figure was not properly visible, but just to give you a hint again, what was given to us? A pipe was given to us. This was the pipe. So for the pipe, outer radius was given to us 4 centimeter. Now on the pipe there is an insulation. For the pipe material, thermal conductivity is 0.1, and for the insulation material, thermal conductivity is how much? It is, for pipe material it is 15 watt per meter Kelvin, and for the insulation it is 0.1 watt per meter Kelvin. For the insulation and outside air, coefficient of convection is 20, and for the pipe and inner fluid, coefficient of convection is given to be 15. Okay? Now guys, let me ask you a question over here. So right now, let us suppose that thickness of insulation is 2 centimeters. What I'm saying, that currently the thickness of insulation is 2 centimeters. So I think if the thickness of insulation is 2 centimeters, so how much is this dia? 4 centimeter. So what will be the outer radius of the pipe? Outer radius of the pipe will be 2 centimeters. What is the thickness of insulation? 2 centimeters. So what will be the outer radius of insulation? 4 centimeter. है ना? So right now the outer radius of insulation is 4 centimeter. My question is, if we add more insulation, what will happen to the heat transfer rate or thermal resistance? What is my question? That right now the outer radius of insulation is 4 centimeter. What will happen to the heat transfer rate if the more insulation is added? So guys, we also know that total thermal resistance versus R2 graph goes like this. And this R2 is minimum at RC when R2 is equal to RC. Now how much is RC? RC is 5 centimeter in this case. RC is how much? 5 centimeter in this case. So what is the current value of R2? Current value of R2 is 5 centimeter. That is less than 4 centimeter. That is less than 5 centimeter. So current value of R2 is 4 centimeter. So thermal resistance will be this much. Now when I will add more insulation, R2 value will increase. R2 value will increase. This means the graph will move towards the right. So resistance will decrease, achieve a minimum and then increase. है ना? So resistance will initially decrease, achieve a minimum and then increase. So heat transfer rate will initially increase, achieve a maximum and then decrease. So in this particular case, if you are increasing the value of R2, resistance is initially decreasing, achieving a minima and then increasing. Heat transfer rate will initially increase, achieve a maxima and then decrease. I hope this is understood. Now the same question can be modified in a different manner. They say that let us suppose initial value of R2 is 7 centimeter. What is the initial value of R2? 7 centimeter. So initial value of R2 was 7 centimeter. Then this means the graph is initially here. So when you will add more insulation, you will move towards the right because R2 value will increase, the resistance will increase and the heat transfer rate will keep on increasing. है ना? So if R2 is less than RC, then adding up insulation means heat transfer rate will increase and then decrease. But if R2 is greater than RC, then heat transfer rate will only decrease. It will not increase. ठीक है? तो ये difference है दोनों दो forms में. Now let us see the next question, which is actually on the same criteria. So what it says a 10 mm diameter electrical conductor. So basically the radius of electrical conductor is given 5 mm. Is covered by an insulation of thickness 2 mm. This means the thickness is 2 mm. If the thickness is 2 mm, so initial value of R2 is R1 plus thickness, that is 7 mm. So initial value of R2 is 7 mm. The conductivity of the insulation is 0.08 watt per meter Kelvin. And the convection coefficient at the surface is 10 watt per meter square Kelvin. 10 watt per meter square Kelvin. Okay. Now it says, what will happen on addition of further insulation? So guys, I think for this insulation whose thermal conductivity is 0.08 and coefficient of convection is 10, I think the critical value of R2, which is K by H, that will be 0.08 by 10 meters. So that will become 8 mm. है ना? I think that will become 8 mm. So the critical value of outer radius is 8 mm. So we also know when the value of R2 is equal to RC, the resistance is minimum. And how much is this value? This value is 7 mm. Sorry, 8 mm. How much is this value? 8 mm. Now, how much is the initial value of R2? So, I think initial value of R2 is 7 mm, which is less than 8 mm. So, this is the initial location of the graph. This is the initial value of resistance. Now, when you add material, what will happen? R2 value will increase. It will move towards the critical point. So, resistance will decrease. If the resistance will decrease, the heat transfer rate will increase. Now, beyond critical point, the resistance will increase. Therefore, heat transfer rate will decrease. So, when you are increasing the value of R2, initially the heat transfer rate is increasing and then it is decreasing. So, what you will say, what will be the correct answer? You will say the increase in heat loss to a maximum and then decrease in heat loss. Increase in heat loss to a maximum and then decrease in heat loss. Guys, I hope the question is clear to all of you. This is a very simple question and even if there is doubt, you need not worry at all. Doubts तो कभी भी आ सकते हैं ना, है ना? पर doubts को पूछना बहुत जरूरी है. Doubts को clarify करना बहुत जरूरी है. Okay, let's see the next question. Next question is actually a very simple one. This question we have already discussed just now, just a few minutes back. So what it says a plastic sleeve of outer radius 1 mm. Outer radius. So outer radius means R2 value. Covers a wire whose radius is 0.5 mm. So this is R1. Carrying electrical current. The thermal conductivity of the plastic insulation is 0.15 watt per meter Kelvin, and the heat transfer coefficient on outer surface of the sleeve exposed to the air is this. So K is given, H is given. Due to addition of further plastic cover, the heat transfer from the wire to the ambient will. Okay. So if we add further insulation, what will happen to the heat transfer rate? Okay. Now guys, check. So what you will say? Again, you will find out the critical radius, which is K by H. That will become 0.15 by 25. I think this will become 0.03 by 5. And that will become, I think this will become 0.03 by 5 is how much? So this is 0.6 by 100. 0.6 by 100, so 6 by 1000, so this will become 6 mm. So how much is this? 6 mm. This is 6 mm. So what is the critical radius of insulation? 6 mm. Guys, please do check. I hope I have done correctly. So 15 by 100, that will be 3 by 5 upon 100 only. And 3 by 5 is 0.6. So 6 by 1000, that is 6 mm. I am doing it correctly. No problem at all. Now what will happen? So critical radius of insulation is 6 mm. So when R2 is equal to 6 mm, the resistance will be minimum. So R2 is equal to 6 mm, the resistance will be minimum. What is the initial value of R2? That is 1 mm. So when you when you add material, you will move towards the critical point. Resistance will decrease. So heat transfer rate will increase. So the complete answer is initially heat transfer rate increases and then decreases. But the complete answer is not given over here. है ना? So what happens to the heat transfer rate? Initially it increases. So we will mark the answer increase. So हमें complete statement नहीं दिया हुआ है ना? मगर इनिशियली हीट ट्रांसफर रेट का क्या हो रहा है? वो डिक्रीज कर रहा है. तो अगर वो इनिशियली हीट ट्रांसफर रेट का क्या हो रहा है? वो इंक्रीज कर रहा है. तो मैंने ये ऑप्शन चूज कर लिया. ठीक है. So guys, I think that's all. So let us see that question which I was saying that the question is wrong. There is a mistake in the statement. Guys, what I want to say is that for a particular value of R2, there will be R conduction and there will be R convection and there will be a heat transfer rate. But heat transfer rate through the conductive resistance or heat transfer rate through the convective resistance is going to be same because this is a series connection. है ना? Now if you will increase the R2 or decrease the R2, the total resistance will change. Accordingly, the total heat transfer rate will change. But at any time instant, whatever is the heat transfer rate in R conduction, the same will be the heat transfer rate in R convection. I hope this you are getting the point. So if the heat transfer rate in one is 100, in the other also it is 100. If the heat transfer rate in one is 50, then in the other also it is 50. So what you say? The total resistance changes and the total heat transfer rate changes. Overall heat transfer rate changes. But you do not say that heat transfer rate in one resistance increases and the heat transfer rate in the other resistance decreases. Because then they will become unequal and it won't be a series connection. ठीक है ना? आई होप आपको ये बात समझ आ रही है. मैं क्या कहना चाहता हूं कि जब आप R2 की वैल्यू चेंज करते हैं तो टोटल रेजिस्टेंस चेंज करता है और यस उसके अकॉर्डिंगली Q डॉट भी चेंज करता है. मगर R कंडक्शन और R कन्वेक्शन जो है वो सीरीज में है. तो R कंडक्शन में जितना Q डॉट होगा उतना ही R कन्वेक्शन में Q डॉट होगा. सो Q डॉट कैन इंक्रीज और डिक्रीज बट इट विल रिमेन सेम इन बोथ द रेजिस्टेंसेस बिकॉज दिस इज अ सीरीज कनेक्शन. है ना? सो व्हाट यू विल से द ओवरऑल रेजिस्टेंस चेंजेस, द हीट ट्रांसफर रेट चेंजेस. है ना? लाइक दिस. नाउ चेक. विद एन इंक्रीज इन थिकनेस ऑफ इंसुलेशन अराउंड अ सर्कुलर पाइप, the heat loss to the surroundings due to convection increases while that due to conduction decreases. So actually what happens when you increase the value of R2, the surface area increases. Surface area increases, therefore R convection decreases. So as per this, the heat convection rate must increase. If you increase the value of R2, the thickness of material will increase. So there is more material to offer the resistance. So R conduction will increase and Q dot conduction will decrease. They are saying like this. But please note, at any instant of time, these two values are equal. ठीक है ना? So better होता कि वो ये नहीं बोलते कि कंडक्शन का जो हीट ट्रांसफर रेट है वो इंक्रीज कर रहा, वो डिक्रीज कर रहा है और कन्वेक्शन का हीट ट्रांसफर रेट इंक्रीज करना है. They should not say like this. ठीक है ना? So the correct question would have been, what will happen to the thermal resistance? R conduction will decrease, R conduction will increase. Like this they should have written. So I hope you get the point. Heat loss to the surroundings due to convection increases, while that due to conduction decreases. So convection decreases, conduction increases. Both decreases, both increases. है ना? So based on this, the correct answer is convection will increase and conduction will decrease. है ना? Correct answer is this. But please mind, this is not the correct form of statement. ये correct form of statement नहीं है क्योंकि overall heat transfer rate change कर रहा है. ठीक है ना? So anyways, that was all from my side. These are like previous year gate questions only. तो ये जो मैंने वीडियो रिकॉर्ड किया है ये स्पेसिफिकली सभी के लिए है देखा जाए तो, मगर ये उन स्टूडेंट्स के लिए काफी यूजफुल है जिन्होंने जस्ट अभी मेरे साथ हीट ट्रांसफर कर रहे थे या कर रहे हैं. सो आज 2 दिसंबर है, आज मैंने ये रिकॉर्ड कर दिया है. सो आई होप सो कि आपको कल परसों में ये वीडियो मिल जाए. ठीक है? सो थैंक यू सो मच. सो लाइक दिस I am recording the videos. 2 वीडियोस मैं ऑलरेडी रिकॉर्ड कर चुका हूं जो शायद अभी आपको नहीं मिली है, इंट्रोडक्शन की, और एक चीज और है वीडियो. कौन सा वीडियो किया था? लंप पैरामीटर के प्रीवियस ईयर क्वेश्चन करे थे. अब मैं बाकी चीजों के भी बनाऊंगा, रेडिएशन के, हीट कन्वेक्शन के. सो कल का भी कुछ प्लान है. ठीक है? So thank you so much. I hope the video is received by you soon. तो अपना तैयारी करते रहिए. 2 दिसंबर आ गया है, रिवाइज कीजिए बहुत सारा. रिवीजन इज द की टू सक्सेस. ठीक है ना? सो मैं किसी सर का वीडियो देख रहा था. वो सर बहुत फेमस है, मैं उनका नाम तो नहीं लूंगा. नॉट फ्रॉम योर ब्रांच, फ्रॉम सम अदर ब्रांच. ठीक है? कंप्यूटर साइंस के सर हैं. तो वो बोलते कि जैसे जब आप कुछ चीज अचीव करना चाहते हैं तो पैशन जिसको बोलते हैं, पैशन होना चाहिए. पैशन में 2 चीजें होती हैं, एक होता है लव और एक होता है हेटरेड. सो आपको किसी चीज का लव होना चाहिए कि मुझे आईआईटीज में जाना ही है, मुझे पीएसयू का जॉब करना ही है, और आपको अपनी करंट सिचुएशन में हेटरेड होना चाहिए. तो आप अपनी सिचुएशन से इतना फेडअप हो जाएंगे कि अपने गोल को अचीव करने के लिए कुछ ना कुछ तो करेंगे ही करेंगे. मैं ये कहूंगा कि हेटरेड तो मत रखो मगर सेटिस्फाई मत रहो. अपनी करंट सिचुएशन में हैप्पी रहो मगर सेटिस्फाई न रहो. ठीक है? तो ऑल द बेस्ट. सी यू सून. थैंक यू. बाय बाय.